Hello and welcome to this webinar for SWEPT. SWEPT is a project with the aim of securing websites through malware detection and attack prevention technologies. We'll explain a bit more about that later. SWEPT is a project which is currently ongoing and is partially funded by the European Commission. We expect this webinar to last approximately an hour. The first 40 to 45 minutes so we'll be explaining about the SWEPT project and the SWEPT product itself. We'll run a short demo of SWEPT so you can see it working live, and we'll explain the added value of SWEPT and invite you all to test it yourselves. Lastly, for about 10 or 15 minutes at the end of the webinar, we'll run some question and answers. To explain what the SWEPT product is and how the project came about, we'll first give you a little bit of background on the landscape as a whole. It's no secret that cybercrime is a huge problem and an increasing one, but what do we actually know? Well, we know a few facts. For example, we know that at least 10% of all URLs are malicious. We know that at least 1 million cyber attacks occur every day. And although it's difficult to quantify the exact effect on the economy, conservative estimates show that at least 300 billion euros of damage is done per year. Okay, so there's a huge amount of cybercrime out there, but how do we actually protect end users from this threat? Well, there's a few different approaches. For example, one approach is to actually protect the end users directly, for example with antivirus software on their computer. Another approach is to focus on website security. Websites are at the core of this issue because one of the main ways users have become infected is by visiting websites. And we know that the majority of web applications have some kind of vulnerability on them. But how do web applications get these vulnerabilities in the first place? Well, there's two main ways. Firstly, the developers that code the websites can make mistakes. Secondly, components that the websites are built upon, for example web frameworks and CMSs like WordPress, Joomla, etc., they can have vulnerabilities in the core of their code. And when these vulnerabilities are uncovered, it causes a huge issue because there's millions of websites out there, for example, that have WordPress or Joomla. So this leaves the developers in a difficult situation. They have to keep their web applications up to date, including any frameworks or CMSs their website is built upon, and they have to maintain any custom code that they've created to ensure that that is secure. The SWEPT project was founded to help solve the problem of insecure websites. The project itself is partially funded by the European Commission under the CIP programme. The project started in March 2014 with a duration of 3 years, and there are 11 partners from 6 countries. Here you can see the distribution of the partners within SWEPT. As you can see, there are a few partners in Spain, one in the United Kingdom, one in France, one in Denmark, one in Italy, one in Slovenia. So the core objective of SWEPT is to improve the security of web applications. That's web applications that actually install SWEPT. It does this through 3 main services: protection, detection, and verification. Protection is a preventive measure that prevents attacks before they actually occur. Detection is a reactive measure that actually discovers malware and vulnerabilities on a website after they occur. Verification is then a method of actually verifying that the SWEPT tool is working on the server and is protecting the website successfully. Let's give a bit more detail about the 3 services. The protection service can be split into 2 sub-services: application level and network level. The application level protection service works from within the web application. It understands the logic of the web application, and it can protect against OWASP top 10. The network level protection service doesn't work from within the web application, but it works more generically and can be applied to any web application at all. The detection service can be split into 3 main sub-services: malware, vulnerabilities, and attacks. It can detect all of these issues after they occur. For example, any malware which makes its way through to the web server or already exists on the website before SWEPT is installed can be detected, and similarly with vulnerabilities. In the case of attacks, Any attacks which aren't detected by the protection services can then be detected by the detection service. Lastly, the verification service is split into two main tools, the verification tool and the label tool. The verification tool verifies that SWEPT is working correctly and picking up the issues that it should be. The label service is then a tool which can then apply this result of the verification to the website so the website owner can display the results. The protection and detection services use existing commercial solutions from SWEPT partners. These solutions are combined into the project to produce unified results. These tools are HDiv, MMT, Secure DNS, IP Legion, WebCheck, Web Malware Safe. We'll explain more about those later. The verification tool is developed purely within the project itself. Okay, so who's actually going to use SWEPT? Within the project, we defined 8 types of stakeholders. 5 of these stakeholders we then defined as customers. These are potential end users of the SWEPT product. These customers we defined as website admins and owners. These are people that would want to install SWEPT to be able to protect their own websites. We also defined web hosting providers. These hosting companies may want to install SWEPT on a large scale to protect all of their customers. Cybersecurity providers. These companies may want to recommend SWEPT to some of their clients. Software providers. These companies may want to actually install SWEPT on within some of their software itself to protect their users by default. And web content developers may want to actually install SWEPT for their clients. Okay, so let's explain how the protection service works. Okay, as we explained, the protection service has 2 main sub-services: application level, based on HDiv, an open source Java component, and at network level, based on MMT, a network-based probe tool. At application level, HDiv is able to protect against OWASP top 10 risks. It does this by integrating with foundational software. For example, in the SWEPT project, HDiv has been extended to work with Symfony, PHP framework. At network level, MMT is able to protect against various types of network attacks, which it has rules for. These include denial of service, scans, suspicious behavior, evasion techniques, and various others. At the application level, HDiv is designed to integrate with the technologies that developers already use. These include frameworks such as Symfony, .NET ASP, Struts 1 and 2, Spring. By integrating directly with these technologies, it reduces the burden on developers. As long as they just use these technologies and install the components for HDiv, that's pretty much all they have to do, aside from some basic configuration. By taking this approach, HDiv is able to protect against 75% of OWASP top 10 risks. Now we're going to show a short demo of how the application level protection works. In this demo, we're going to be using a web application which has been developed for the demo in Symfony, a web framework for PHP. And initially, this website here you're seeing has the application level protection disabled, so the website is insecure. On this application, you can view orders from a customer. Looking at one of the orders here, and we can actually change the URL, change the ID of the order, and view another order. And this order is from a different user, so this is an order we shouldn't be able to see. And now we're going to enable the application level protection. And similarly, we're going to see an order that we're allowed to see, then we're going to try and change the URL to see a different order, and we can see that it's been blocked. Now for a second example, again with application level protection disabled, We're going to try to use the editable data field, so essentially a text field, to enter text that we shouldn't be able to enter. In this case, it's going to be text used for an SQL injection attack. And we can see this text using this SQL injection text, we're able to view all the orders from all the customers from the database. Again, something we should be able to do. If we enable the application level protection, we can try the same attack again. And as you can see, we're not able to actually perform that search, and we get an inline error message which shows you why. So we've shown how HDiv works from the user's point of view within SWEPT as application level protection. We're now going to actually test the results of HDiv within SWEPT to show how accurate the results are. Firstly, with the application level protection disabled, we're going to run a tool called Acunetics, which is a vulnerability scanner. It shows vulnerabilities on websites. Using a demo website that we've created, we're going to run Acunetics on this website with application level disabled. And as you probably expect, Acunetics will detect a few issues with the website. You can see already some different vulnerabilities coming through here. It says level 3 high, that means that the vulnerabilities discovered are quite severe. In the list of vulnerabilities, you can see blind SQL injection, cross-site scripting, which are both severe vulnerabilities. And here's the summary: 5 high alerts, 20 medium and 4 low. Now we're going to use Acunetics to run the same scan on the same website. The only difference is the application level protection of HDiv is enabled this time. As you would expect with HDiv blocking most of OWASP top 10 risks, it's going to fix a lot of those vulnerabilities, and you would expect most of those to not appear in the Acunetics results. You can see here from debugging console that HDiv is actually live blocking the attacks which are simulated by Acunetics. Scan's just coming to a completion here. So far you can see that no high or medium alerts have been found, only low. And you can see from the summary there, 22 low level alerts, no high, no medium. So by enabling HDiv through the application level protection, essentially those vulnerabilities on the website have been protected against. Okay, in the demo we've seen how the application level protection is effectively used by the end users as they browse the website, but how is it actually used by the webmaster that installs it in the first place? Well, the application level protection based on HDiv is based on software. It's purely written in software, so it just simply has to be installed as a library within the application. So to install the application level protection is extremely simple. It's simply a case of copying the library into the application and including a configuration file that has the SWEPT configuration within it. That's it. Moving on from the application level protection to the network level protection. The network monitoring essentially monitors network communications, and it can do this at any level, whether it's in a data center or within a web server for a specific website. It works by essentially detecting and analyzing behaviors of communications at the network level. By doing this, it can detect attacks which are known about, as well as attacks which are not known about, which are also called zero-day attacks. The network monitoring is also able to prevent certain incidents from occurring. For example, low security signals, such as attackers who are scanning a network before performing an attack. By picking up these low security signals, you can actually prevent some attacks before they actually occur. Attacks can also be mitigated. This is done by interacting with the firewall and also with HDIV from the application level protection, and by coordinating with these two components, it can be possible to detect attacks and actually block them. The added value of this holistic approach is that you can discover attack behaviors and usage trends over time. You can also block attacks before it even reaches the application. For example, denial of service attacks. These can cause huge problems before it even reaches the application level. By blocking these attacks before it reaches the application, it frees the website up. This approach can also eliminate bad traffic, which essentially serves as noise on the network. Moving on now to the second main service within SWEPT, which is the detection service. Whereas the protection service works to prevent incidents before they occur, the detection is reactive by nature. This means it discovers events after they actually occur. This can be useful in two main scenarios. Firstly, in the scenario where SWEPT has been installed on a website and the website is already insecure and has some issues. In this case, we need detection to detect those issues. And secondly, in the cases where the prevention is not enough and hacks can still occur, detection is able then as a second line of defense. Within SWEPT, we define three types of issues that we detect. These are vulnerabilities, malware, and attacks. There are 6 different tools that work within the detection service. Firstly, there's Web Malware Safe, which is essentially a malware detection tool that discovers malware through a sandboxing type technique. There's WebCheck, which detects malware and vulnerabilities and uses a kind of hybrid scanning technique which scans both locally and remotely from the web server. IP Legion, which is a vulnerability scanning and assessment tool. And there are 3 tools that could detect attacks. 2 that you've heard about already, HDIV and MMT, and also Secure DNS, which detects bad DNS. By using multiple different tools, SWEPT is able to increase the accuracy of its results by not relying on a particular tool which uses a particular methodology to detect certain incidents, but instead using a broader range of tools that uses a broad range of techniques. Without the integration approach of SWEPT, individual scanning tools essentially produce different results. So for example, in the illustration here you see 3 different scanning tools, A, B and C, that produce 3 different reports. If a developer is to purchase licenses for each of these tools and to produce reports from each of these tools, then essentially they're left with 3 different reports to go through. The detection approach with SWEPT is to combine all of these reports from different tools into one final report. We call this aggregation. Aggregation itself is a challenge. There's many difficulties involved in combining different reports from different tools into one unified report, but there are many benefits. Firstly, you can increase the accuracy of the results by drawing different results from different tools that work in different ways. Secondly, you can increase the confidence of your results. For example, if one of your tools is extremely confident about a particular result, but 3 or 4 of your other tools aren't quite as confident, you can make a calculation there that somewhere in between might be more accurate. Similarly, by adjusting the confidence of your results, you can actually reduce false positives. Whereas the protection service within SWEPT works on a real-time basis, the detection service doesn't. It works on a scheduled basis. It executes different scanners at different intervals. These intervals can be defined by the user. For example, a user may want to scan their website daily or weekly or monthly. Similarly, the aggregation of the results and the final report which is produced occurs at these intervals as well. The only exception within the detection module is for the attack detection for application and network level. This is actually performed in real time as well. To enable all of the detection tools to run together and to schedule on time, we had to produce some core software within Swept, namely the scheduler and the Swept core module. The scanner, as you can see in blue, represents the tools that are provided to the project. So these are pre-existing. And all that had to be written for these to be integrated within the Swept solution is just a small wrapper on top of the scanner itself. So this means that in the future, existing tools can be added to the project just by writing a small wrapper on top of the tool, and they can be integrated within the Swept solution. The scheduler itself interacts with the wrapper. This launches the tool. Then when the tool is launched, the results are provided back through the wrapper, and these results make their way to the Swept core module, which are persisted into the database. The outcome of this is then that it produces a report. Similarly, here in orange we see a different tool which undergoes the same process. And in this case, it produces a different report. This process essentially occurs multiple times for the same website on the same period on the same day for each individual tool, and produces a report for each tool for each website. Again, here we see a third tool being run on the same website and producing a third report. Then another process occurs where the Swept core module is triggered by the scheduler to perform the aggregation on the reports. Here we show just 3 reports from 3 tools, but there could be many more than that. And the aggregated report is produced. In terms of the detection of the application attacks, it's simply a case that the attacker that you see here represented by the computer on the left is essentially trying to attack the website. This has to go through HDIV, which works on the application level, and essentially this hacker performs the attack, which is then blocked by HDIV. And then HDIV itself is able to then report directly to Swept, so that the Swept detection service is aware of any attacks which are blocked. Similarly, on the network level, any attacks which are performed by the hacker on the left have to go through MMT at the network level and can also then pass through to HDIV afterwards. And any attacks that are performed that are deemed at the network level by MMT to be malicious are not only blocked, but then also reported to the Swept detection service. As you see there, the application attack and network attack is blocked. Next, we move on to the third and final Swept service, which is the verification service. We've shown already how HDIV can protect web applications from the application level, and we've shown that HDIV can protect against most of the top 10 web risks. But how can we verify that HDIV's protection component is working correctly? We need a verification tool that assesses the security of the web application according to the protection level we've applied. Without Swept, traditional tools such as Acunetics, which we showed in an earlier demo, can be used to detect vulnerabilities, but they don't detect all risks or all vulnerabilities. When using Swept though, we know which risks we should be protected against, as we know which risks the Swept tools can protect against. Therefore, it should be possible to verify that these risks are protected against. We've developed an automated verification tool that does exactly that, It verifies that all of the protection components are operating exactly as they should be. This could be used as well with existing tools like Acunetics to verify even further. Let's explain the verification process in a bit more detail. The SWEP platform offers a way to automatically assess the protection level of a web application in terms of the application level protection. Naturally, this verification service is mostly going to be used by experienced security testers and auditors rather than individual webmasters. These verification tests can be configured and launched through the SWEP portal. Firstly, the verification tool performs a web scraping process in which it identifies the structure of the web application. Once the tool has identified the potentially vulnerable elements, it performs a set of attacks against those elements. Since the web application is protected by HDIV, attacks are detected by HDIV, which sends a response message to the verification tool acknowledging that the attack has been detected and prevented. So the verification tool knows from information from HDIV that HDIV is successfully protecting against this particular vulnerability. This occurs for all potential vulnerable elements in a completely automated process that covers the whole OWASP top 10 list, and this automated process occurs on a regular basis. The verification tool is simple to install and configure. The only prerequisite is an installation of HDIV. The verification tool itself is executed from the SWEP server, so there's no need to install it. But the user has to configure when to start the service and the frequency of the tests. The user does have to configure access control to the web application. In other words, any credentials used to access the web application have to be configured within the verification tool. This is done simply by contacting the SWEP admin. The SWEP label is exactly that. It's a simple label that demonstrates to everyone that a website is secured by SWEP. Each SWEP label is linked to a single website and the service is offered for free with the SWEP platform. The SWEP label is based on the findings of the detection services. For example, it will only be displayed if the detection services do not detect any issues. The label is unaffected by attacks blocked by the protection service. The SWEP label also verifies that the verification scans are successful and therefore that the protection service is running correctly. The full results from the detection services can be viewed from a link within the SWEP label. The user manager can select which websites have labels and which do not. In addition, they will be able to select the level of information that is displayed to users. We've explained the problem that SWEP tries to solve, and we've explained roughly how SWEP works. So what's the added value of SWEP? Why should we use SWEP rather than existing solutions? SWEP doesn't use groundbreaking techniques to discover previously undetectable vulnerabilities or attacks. Instead, SWEP is a holistic solution. Its added value comes from integrating many different tools together into one solution. The tools that SWEP integrates include both preventive and reactive tools. This gives two lines of defense. With these tools, 75% of OWASP top 10 web risks are protected against. And by combining results from multiple tools, SWEP can increase the accuracy of its results and have fewer false positives. The reports are also much cleaner by aggregating into a single unified report rather than having to read multiple reports from multiple tools. SWEP also has a public API that allows third-party functionalities to be added, as well as additional tools to be added to the platform in the future. SWEP also has a lower price than many competitors, especially when the cost of all the individual tools is taken into account. Tools within SWEP are integrated in a modular fashion. This enables customers to purchase only the services that they need. Although SWEP is a new product, tools within SWEP have been on the market for some time and are running in production environments. Additionally, these tools are continuously being updated, improving the features not only within the tools, but within the SWEP platform as a whole. Lastly, the SWEP tools are all provided by experienced leaders within the cybersecurity field. Here you can see an illustrative example of pricing for SWEP. Firstly, you can see that modules are priced based on their capability. For example, detection services is a single module that can be purchased. This simplifies the purchasing for the customer, who does not have to understand the names or the capabilities of the individual detection tools, such as IP Legion, WebCheck or Web Malware Safe. The example shown here is based on a license for operating on one web server. Due to the flexible and modular nature of the SWEP platform, SWEP could be rolled out across a client with many thousands of websites, such as a web hosting provider. In cases such as these, SWEP would instead cost a small fee per website rather than per web server. As you can see, core components of SWEP, including the portal and the labeling, are bundled without cost. Starting from today, we're giving you the opportunity to try SWEP out for yourself. Remember that SWEP is still in development and the project ends in a few months' time, but it gives you an early chance to get a feel for the product and what it does. During the trial phase, SWEP will be operating using all three services. For the protection service, all websites will be supported by the network level protection, but application level support is limited to websites using Java, .NET or PHP for Symfony. The detection service is not limited to any website requirements. For the trial phase, the verification service is limited to websites built on Java. To register for the trial, simply go to the URL listed. You will need to register and await acceptance in order to start testing SWEP. A legal agreement will be sent, and you'll be able to download the user manual from the web portal. A questionnaire will be available to get participants' feedback. We'll send a reminder to all participants to fill in this questionnaire before the middle of January. During the trial, the technical support will be done only by email during office hours, and only to issues relating to the use and installation of SWEP. At the moment, we will not support any issues relating to the solving of threats found. Thank you very much for your attention during the webinar. We hope to answer some of your questions shortly, and we'll speak soon.